This is Peter giving a talk about Dr. Hazel and about AI. So basically, this is Dr. Hazel using AI for detecting skin cancer. So my name is Peter Ma. I'm part of the Intel software innovator. I'm also part of Samsung Champion. I've been through 5 different startups, hundreds of hackathons, and I travel a lot, which is like I've been to more than 33 countries in the past 3 years. So in this talk, we're gonna give a focus on three things. First, what is AI? How does it relate to IoT? And how we build Dr. Hazel, which is a skin cancer detection. So there's a lot of buzzwords around this recently. So it's like machine learning and deep learning. It has been on the news. It has been in in every product. It seems to be integrating with it, but in reality, nobody really knew what it is. And especially hackathons, everyone says, "Oh, we integrated machine learning," but in reality, nothing is done. And it's more of a theory of how this should do, and not really what it is. So the question we come into is like, what is AI? Well, AI contains, artificial intelligence, which was created in the 50s to play checkers and chess and basically games. And the game logic to make its own moves and own decisions. And in the 80s, there was machine learning, where you can use data to predict a lot of things. In 2012. Computers finally able to detect what is a cat and not a cat. So before in 2012, the computer does not know what cat is, or when I see a picture of cat, it simply does not recognize it. And there's other areas such as voice detection using a bot. Those are a different type of things. But in this, we're going to focus more on deep learning. And the difference between machine learning and deep learning is machine learning is more of an extracting featuring one layer, where deep learning is basically you putting all the data in and then expect the computer to make its own categorization. This is a primary algorithm used for machine learning and deep learning. It's called ANN, the artificial neural network. And this is mostly common through deep learning. Is called convolutional neural network. So let me give you one example. Previously, I built an app called the anti-snoozer. It's basically detecting a person's drowsy or not. So my very first iteration was basically using OpenCV to plot all the maps on your face. And when I see the mouth part is opening up, that's those two dots are opening up, I know the person the mouth is opening, so therefore the person is yawning, and that's how I was able to detect. But this is regular machine learning. I'm putting one layer of extraction and basically say when those two dots, one x26 and x48 or distance are more than certain millimeters, that means the person is opening mouth and yawning. But in deep learning, you would be able to putting tons of photos of the person that's yawning and tons of photos of that person that's just normally driving, and the computer would build out its own model and say, okay, this person is yawning and this person is not while driving. That's one of the example. A separate example is this. It's like, so on Tinder, you would have everybody swiping left and swiping right. And eventually you'll be using the data without the computer actually seeing who it is, without computer actually seeing the photo, but the computer is able to tell who's attractive and who's not based on how many likes or how many swipe left and how many swipe right. But this is through machine learning you'll find out who's more attractive. But in deep learning, what you would do is having thousands and thousands of people's photos, like model photos or whatever photo that you're looking for, and the computer will eventually train, who's attractive and who's not. The computer will basically using that data through neural networks and find out who's attractive and who's not. It's basically a replication of a human neural network. How does this actually work? As explained, like, so it has three. In deep learning training has three models: you train, you validate, and you test. The first is with the training thousands of photos using multiple layers, and eventually we'll see the human face. This is you basically just simply inputting all the photos and parameters of how to train. The traditional one, like I said earlier, you have to extract specific feature that you're looking for to get the result that you want in order to categorize. And it acts the deep learning, deep learning basically go through like a normal human neuron, where you extract the information through layers, and then you basically dismiss. You basically start forgetting the stuff that's not important, and eventually you're only looking for the thing that's different than the other. This is the structure of artificial neuron that that we all using through pretty much every framework. So convolutional neural network layer through LayNet explained in this way. So you initially have convolution, then you subsample, you convolution again, and you subsample again. One of the example I can give is basically, so think of a Photoshop layers. So for every layer, you would have something different. So first layer, you might have a contrast. You can take the contrast out so the shape can come out a little more clear. A second one, you can use color. A third one, you can use different, as you go, you can use like blur, the lens blur, and then each layer. And when you extract all these layers down in the end, the Gaussian, there's Gaussian and there's all these blurs, and eventually you will have the shape that you want, and then that's a shape that's different from one model to another. So now you will know the cat is cat and a dog is a dog. After all these layers down, you can make a determination of what the object actually is. This is how it does. You input the convolution, put an input, and through all these layers, you will have an output. Output is a model through all of the training data of all the differences and similarity. Like over here, a cat. Once you do a contrast, you can see, you can see, okay, everything else is a background. After training input, from layers, top layer, and output, eventually you will know what is a wolf and what is a dog. And in between, you can see, there's tails, there's edges. Those are, different things that you kind of train. And training curve are never 100% accurate. It's just still replicating of how human would do it. We usually train around, I personally train around 4,000 iterations, but you technically supposed to train over 100,000 data, the image data set, and then over 10,000 iterations to get a normal model that works, that can determine what categorize it is. So unless you overtrain it, usually 95% or over 90% is what you're looking for. So always remember, this is just like human being. Like you can say, oh, the AI make mistakes. The AI is not as accurate as I thought. Remember, this is like humans are not as accurate. So then this is simply just a replicating human neuron. So there's a limit. That's where one of the limitation for this is. The second limitation is categorization, because deep learning is mainly used for categorizing. And after you reach over 1,000 categories, it becomes a little more difficult for the AI to recognize new objects. And this is also replicating the human, how we only have categorized 1,000 things. How Apple's iPhone 10 works is that it categorizes whether it's you or not you. So there's technically only 2 categories, which makes the accuracy up a lot, because they're simply detecting whether this is you or not you. Different frameworks currently support. A lot of frameworks start coming out. Cafe is developed by Berkeley. TensorFlow supported by Google. Cafe 2 is by Facebook, and Neon's by Intel. And there are also there are So personally, I've trained them on using Cafe. And there are also a graphical interface Intel has provided. You can train your model by using thousands of images. So another thing is that the majority of the AI out there are using a cluster server. You basically put an image up, and then you get a result. Microsoft has shown many demos of this for age and gender recognition. That's part of their demo. But also, Intel has been coming out with the Movidius NCS, which you can do all the neural network locally. This way, you do not need a connection. And there's a lot of pros and cons for each. The pros for using a cloud is that you have a single layer. When you can scale, all you have to do is scale more servers. And when you get so it doesn't cost you more than what you need. The advantage of using a local neural network locally is that you can actually implement this in every single IoT device. Now it contains the computing power of artificial intelligence in real time. There's a lot of examples I'm going to discuss. So first of all, it's like a lot of this is a DevFest for IoT. So first you might ask, like, how does all this fit into IoT, Internet of Things? Well, with the AI, you now the things can see, can hear, can learn, and can decide. This is where without these, IoT is just a bunch of sensors, connecting sensors, sending out some data. But with the power of the artificial intelligence, it can do a lot more than that. As first, we can see to become the eye for IoT. The cameras now can basically recognize images. It can do image analysis and much others. So some of the examples you can see the Phantom, the Phantom all of the Phantom DJI has the Movidius mirrored chip, which allows which allows a drone to actually follow a person around. And that's the building deep learning models across the entire spectrum of devices. Second, you can see one of the examples for these iPhone 10. The phone itself runs AI in real time, where you can see is it me or not me. Using traditional machine learning models, you would not be able to when a person wear a hat or wear the beard, it's very difficult to actually recognize that. But with deep learning, you can easily recognize a person. Autonomous vehicles is another area where the Internet of Things has really integrated with the artificial intelligence. It is able to see, determine what's around, and then how dangerous they are. So here is IoT. Currently, again, without AI, is more of just a sound sensor. How loud, how and what it does. You can see a graph, but with it, you can basically see hearing sound, voice recognition, sound, and differentiation. Some of the examples that we see in the current world is Alexa and Google Home. Those are heavily integrated IoT devices that uses AI in the cloud. It's one of the good example what's a cloud versus local, because to have all that languages and to have all that features, it's much easier for the cloud to recognize compared to image model that we use locally. But there's also other things that can be used locally. Intel actually hosted a challenge on the Earth Day, so we can recognize bird migration. This is one of the examples where AI can use for bird migration. That you can determine what bird and at what time that's being used for the what time of the year that's actually migrating through the area. Another project that's kind of cool is that they use AI to determine whether the sound is a natural forest sound or as a chainsaw sound that's for illegal logging. Those are some of the examples that can be integrated from using AI and IoT. Learning, of course, the AI's the whole point of the deep learning is learning. And it can basically improve the current process and remove repetitive tasks from human beings. And there's tons of these, landscape that all these technologies will be able to change because of learning. Almost every industry will be changed. You can take a look at it. You can take a look at it. Like if but same time, people would always talk about, there's going to be a lot of job situation that's going to be different. That is technically true, but at the same time, there's a lot more jobs going to be created. For example, training AI, right now there is really no jobs on training AI, and this is actually a lot of work on getting the models right. So in the near future, you can probably see jobs such as, deep learning trainer, just like because you're technically training this machine, just like how you would train your pet. And deciding filtering is another part of how AI would integrate into IoT. The security cameras right now cannot detect everything. And also, whenever police sees, this is one of the example by one of the Intel student ambassadors, is that right now the police simply cannot see the missing children, because there's too many of them and it's too difficult to match. Using AI, whenever you see a person that's a suspect of missing children, you can actually filter them down to just a few that you think that they look alike. This way, you greatly decrease the sample size of the missing children that you're looking for, and that that can improve your accuracy as well as reduces all the time that a person will be looking. There's just too many missing children and not enough resources, and AI basically is the area that can really help in that area. Let's move on to Dr. Hazel. This is basically Dr. Hazel. We are basically a real-time skin cancer detection using powered by artificial intelligence. So as a very first task for deep learning is that you train yourself for things like, cats and dogs. This is image is provided by Kaggle, and this is one of the first example that in the world where we determine whether it's a cat or not a cat. And somebody who's new getting into AI, that's what I got myself into. And eventually, just like the joke from Silicon Valley, this is like dog or not hot dog. You can simply using the exact same logic determine that. And this is actually the exact same logic that iPhone uses to determine whether this is a you or not you. Believe it or not. So at TechCrunch Disrupt, after knowing this basic skills, we've decided to build out a skin cancer project because my co-founder Mike was he was going to the dermatologist a lot and then just trying to worry about a new mold that he was getting. And we did some data research, and we found out that 40 to 50% of Americans will get some sort of skin cancer by age 65. And there's over $8 billion being spent treating skin cancer in the US alone. The survival rate of early detection is more than 98%. So we actually built out that entire project. Our vision is actually to give everyone a free cancer screening, where patients can engage with the dermatologist for biopsy when to get the real treatment. This way, the AI can help to diagnosis, and then the dermatologist now can simply do all the procedures for removal and then for treatment. These days, the healthcare price is going more and more, and also the getting specialist appointment is getting worse and worse. So we remove all these tasks from dermatologists. So, for example, I had a toothache. I went into my dentist office and they just said, "Oh, your gum is receding. Get out of here." And my copay is $10. He probably made around $50 for the checkup. Compare if there's actually a filling for the exact same amount of time that he spent with me, he would have made around $250 to $400 for that filling, and I probably copay around the $30. So there's the diagnosis is really not where the money comes from for doctors, especially when they just look at you. So you're not really removing any of their tasks. You're actually giving them more tasks on treating people with actual cancer. And this is one of the solutions. Is we provide Dr. Hazel to places like pharmaceutical or primary care, where they can do the initial screening, and then if they determine this person, the mole is a high confidence, we use a confidence rate of having a melanoma, then we refer them to the dermatologist. This is to save both time and money. And we can do both on the initially we can do both on the phone and as well as devices in the pharmacies and primary care. Our sources data we use is from Stanford, University of Washington, Fred Hutch, and the UCSF. Currently, we are basically using around 1,000 photos of each. Basically, 1,000 photos of a regular mole and 1,000 photos of cancerous mole. And through this, we're able to train out, determine between 75 to 80% cancer detection. So our teams include me and Mike. Mike has been 20 years in software, and spent 9 years in DocuSign as one of the first employees there. And he has been the executive at multiple startups. I'm part of the Intel software innovator, focusing on AI. And I've been consulting for Verizon for over 4 years, building different prototypes. Also been 5 different startups, including one of them EMR. So this is one of the demo that we were giving at the Strata conference. We had around 400 people interviewed, and then 70% of them actually wants this to be in either pharmacy or primary care, so they can be a lot more accessible. We built this actually in September 16th, and within around 2-month period, we were covered by TechCrunch, Wall Street Journal, Mobile Health News, and tons of other press. And then we also received hundreds of emails from people who were interested, including investors, previous patients. And it's kind of interesting to see all the people excited about this product and about AI. Let's see a demo. The current tool actually only runs on Ubuntu. As you can see, there's just this machine over here. This is a Movidius. This is the Movidius NCS stick, and we're using this camera, endoscope camera. The accuracy is about right now, like the training models, between 75% to 85%. When we put a lot of more dummy data, it becomes around 85%. But if you do just between melanoma and the benign and non-benign, with 1,000 images, we got to around like 80%. And if you decrease a data set a little more, it becomes 75%. Well, we're looking for a lot more data, so this way we can get more accuracy up. That's one of the easiest way. Let's just see a demo for you guys. So the video, I gotta get the video thing right. Video ports. So as you can see, so let's see if we were to see a melanoma photo. Maybe this one. You can clearly see the image recognition for melanoma. But if I was to do this on myself, my own moles, and this is confidence rate. This is not this is not probability. This is more of a confidence. How much confidence this thing is. It's just a nevus mole. Let's check out another mole on just a mole. As you can see, this is, and what you see down there is basically the confidence rate. And tools like this can easily be integrated. Do you create a training set or get it somewhere? I create my own training set. And right now, most images are from ISIC and University of Iowa. So, if you're more interested, you can kind of see go to drhazel.com. Our Facebook is at Dr. Hazel, and then our Twitter is at Dr. Hazel AI. Feel free to check us out. And this all came from just training dogs and cats, where we moved this into training the skin cancer and not skin cancer. My name is Peter Ma. You can email me at peter@drhazel.com, and then my email, my Twitter is NOICENE. What was the feedback for any doctors specializing in this tool? There's a difference between the primary doctors and then the dermatologists. The primary doctors actually want this tool in their office because they're a little concerned with the accuracy, and then they were also concerned whether the device is FDA approved. So there's two things that we're still looking for. One is getting the FDA approval for the device and for a diagnosis tool. The second is basically getting the more data from institutions like UCSF or Stanford or University of Washington. One second, let me go with the second question. Have you explored the cost barrier of introduction for the developing area, deployed at low-cost hardware? Yes, that's what we're trying to do. What we're trying to do next is basically we're gonna get we're gonna try to get more data so we can get the model a lot more accurate. Up to if we can get to around 97%, then we can basically deploy hardware, low cost hardware across the area. Our goal isn't really to sell to consumers, but rather to the places like pharmacy where you can get access to. We have interviewed a lot of people, so it seems that the only people who are interested in these type of devices at home are the previous cancer survivors, and they really want this at home, so whenever they have a new mole, they can check it. But for the general public, they're like, oh, I would love to, because my question was this: after seeing this demo, this device exists. Where would you like to see it? Whether in primary care, in your in dermatologist office, in pharmacy, or at home, and over 70% of people expecting to see this in primary care, family doctor, or in the pharmacy. Have you reviewed with any cancer docs? Yes, we have reviewed this with the cancer docs, and the dermatologist is actually pretty interested in this. But then again, the concern is how do you get FDA approval on top of this to be an actual diagnosis device and not just a cool demo that you show people. This is actually a live demo, so it can be used in in different areas. Leave a small. One problem with the camera is not meant for If scanning a leaf or plant by smartphone can deter leaf or plant by smartphone, can I determine the health parameters such as photosynthesis, nutrition deficiency, and disease? Please give some guidance how to start the proceed. So that's a little more difficult. So Shri, you have to think how this works is basically replacing replicating tool of replicating function of a person, look at a thing and determine what it is. For example, ornithologists, they look at a bird, they go, okay, this is a pigeon, and that's a blue jay, and that's a Stella jay. That's because their overall experience, they have seen thousands of birds, and then now when they see a bird, they know exactly what it is. And same with the dermatologist. They see these cancers mole every single day, so they're like, when they see a mole, they're like, oh, this is a mole, this is a melanoma, that's just a keratosis. They know based on their experience, and they can see all these things. And as a zoologist, you go to a zoo, you're like, oh, that's a hippo, that's a giraffe, that's an elephant. But the thing is, when you, let's say you've never seen an elephant before, but you've seen a giraffe, you can go to a zoo, you're like, oh, what is this? You don't know what it is. And for using deep learning, it's just a replicating of that It's just a one replication of what that is. So you're basically replicating exact training method of how you would train a human being. Does that explain any? Does that explain how this works? So in other way, if you have thousands of photos of a nutrition deficiency of a plant, and thousands of photos of a healthy plant leaf, and thousands of photos in between, and this way the AI can determine, it's like, okay, this one is not getting enough sunlight, or that one is drying up. If that's if that explains. How's Dr. Hazel? You're welcome, Bob. How's Dr. Hazel compared to IBM Watson? Well, I have not used every IBM tool, but IBM's tool is mainly used for cognitive. So their AI is what cognitive is basically using training, not really training. Is used basically determining an article and what's a verb and what's not, so you can extract like summary and do a lot more cool things with it. That's at least part of the alchemy. So Dr. Hazel is more of using deep learning method of how you train, how you would actually train. It's basically like iPhone 10 method of how would you determine if this is you or not you, if it's a hot dog or not hot dog, and which in this case is whether skin cancer or not skin cancer. That's kind of the same the model we're going towards. And also IBM Watson is based on cloud, and there's this is the Intel's Movidius neural computing stick is based on local neural. So the computer does not need to be connected to the internet for all this to work, which you can send the data later on. But the thing is, you can actually run the AI locally. And this helps things like drone, like DJI Phantom contain all these tools. So when you're going around, the drone will follow you. But imagine going up the cloud and come back all the time. That's actually very tiring. If the connection disconnects, then the bots and drone all of a sudden would just stop functioning. This is why the AI should be more towards local. I think AI can help agriculture. Yeah, the AI can definitely help agriculture a lot. Determining what plant is like. Basically, you can see, you can monitor, because very big part about AI is basically monitoring and seeing and so you can make the decisions. If you look at the farm every single day, and a farmer would know what's wrong, and then and then in this case it will be like, oh, there's a wheat growing, so we gotta go kill the wheat. Instead of using chemical, they can using AI as an alternative solution. One more thing about the agriculture part. This is actually for inventory as well. So you would think like these the technology growth is from like the 4th stage of growth. So initially we use a pen and paper. We write down as agriculture every single day, like, hey, how many of the potatoes are on this tree, right? The 2nd stage, you try to use the iPad or using your phone. You're like, okay, I have built an app, but that's still manual input. And 3rd stage is basically IoT. You install sensors to detect, how many fruits on this tree. But then again, that provides more problem than it solves, because now you have to maintain all these sensors. And 4th is basically using AI. So when the image goes through, immediately will give you an amount of data in that brute force way. So you don't have to worry about it. It's actually much more cheaper in terms of for many things, not for all things, but for many things, is much more cheaper than the regular implementation of using sensors. Because at the end of the day, it's just a camera. And then you're using intelligence to determine. It's actually brute force of human intelligence to determine what should be there. Do you need sensor on patients? So for Dr. Hazel, no, you do not need a sensor on patients. So this becomes the device becomes a sensor. So this way you can determine whether the person, using the deep learning model, using the AI model, you can determine whether that's a melanoma or not right away. That's what I was saying. It's like the AI becomes a sensor. Okay, how do you follow human skin? Can you elaborate that? Like, how do you follow human skin? So this is just a camera. So whenever, let's say if I have a mole here, I can easily just get a mole here and then get it checked. Let me see. Yeah, like if I have a mole, let's see if I have a mole anywhere on my face. I have a mole here. And then I'll show you the other screen. Because training data contains a lot of hair too, so it doesn't really matter I have hair or not in the photo or not. This is actually remote into the it's a little slower, but it's like kind of remote into the remoting into. Why not use sensors? There's cases where you would use sensors, and there were cases where you use AI. So use sensor, first of all, has become much more expensive, and this is much more cheaper. So then, analysis offline, so that you can kind of like sense everywhere, so that everyone can have a skin cancer detection. Second is like, in order to build a cancer sensor, you have to build a cancer sensor. That requires that requires entire different technology. And in the commercial world, at least we're trying to achieve is, if we want to provide everyone free skin cancer screening, this is one of our ways of trying to do, as affordable as possible for all the patients out there. That's that's one of our goal, is basically to do that. If you want to learn more about AI, you can easily go to Intel's BDL. You mentioned you're waiting for FDA approval. What are the requirements, steps, and blockers you guys are facing? So currently we are right now, first of all, this is we talked to some other companies, but they were basically more of a detection tool. And this is a diagnosis tool. So apparently we have to go beyond just the normal health device. Due to the nature of this, we actually need a clinical trial, basically, to determine how accurate from this is with the dermatologist's result. But that's doable because there's a kid from Stanford. He was on Nature early this year, cover of Nature. He was able to build a model using 130,000 images that matches 26 dermatologists' result. So we know that's a benchmark that can be achieved once we get the data. Also, but the thing is, once we understand how much it will cost, it's much easier to tell the investors how much we need to raise. Right now, that's a big block because we don't know how much it's going to cost. We have a rough estimate, but we don't know how much this is going to cost us to go through the process of our diagnosis as well as clinical trial. Hope you guys enjoyed this. You can learn this. The deep learning and AI is a brand new field, so it's just getting really hot lately because people finally can determine what it can do. It was pretty interesting. Before, everybody was like Facebook, Google, they were all giving demos at their conferences, but there was not practical applications before, and that's why it didn't draw a lot of people's interest. Now, Dr. Hazel is one of those applications where people can relate. It's like, oh, this is really interesting. This is not just determine this is a horse and that's a cat and that's a dog. So yeah, it can do much beyond that. But there is also a lot of more ethical that comes with it as well. For example, recent news, you can see that people trained tons of models for gay and straight. So all of a sudden, you can determine whether a person's gay or straight based on the AI is telling. So there is a lot more ethical grounds we have not broken yet. We were going to see what the future of the AI lies ahead of us. All right. Thank you, guys. If you have any questions, feel free to contact me at .NET Pete gmail.com. And good luck, and I hope you guys will learn AI as well and come up with interesting applications.